Okay, starting with number 21 on this one, very similar to number 20 that we did on the last one. I am working with the secant, however, this time of the square root of 2. So as usual, working with secant instead, I'd rather work with cosine, the reciprocal of that. So when I flip this upside down, I'm going to get 1 over the square root of 2 and rationalize my denominator so that it matches up with something on my unit circle. So the square root of 2 over 2 is what we're looking for here, the angle where that happens. And again, it asks me only to work between 0 and 2 pi. So let me look at my all students take calculus. And I'm looking for where cosine is going to be positive, since we've got a positive value right here. So I know cosine is positive here. They're all positive here. I know that sine is positive here and tangent is positive only here. And so cosine is also positive down here in the fourth quadrant. So I know that my answers are going to be in the first and the fourth quadrants. All right, let me also look for my reference angle here. So I'm going to bring that cosine over to the other side. Anytime we use that inverse to help us find an angle, I'm looking for where is cosine, the square root of 2 over 2. Let me jump back to my quadrant 1 again that I made in a different video. Find it. Oh, there it is. And I want to find where my x value, where my cosine, is the square root of 2 over 2. And here it is right here at pi over 4. So I'm going to say that my reference angle here is pi over 4. So in the first quadrant, the reference angle is that angle. So I'm going to be working at pi over 4. And then I want to work down here in the fourth quadrant. And so I know this right here is 2 pi or 8 pi over 4. So in the fourth quadrant, I'm going to call that 7 pi over 4. Okay, on 22, they're asking me to find where tangent is undefined. So you can think about your graph on this one if you want to. I'm going to go ahead and stick with my all students take calculus and kind of my coordinate plane here. And I know that tangent is going to be undefined at a place where I have something like 1 over 0. So I'm looking at my quadrantals here. And I also know that tangent is y over x. I'm only looking between 0 and 2 pi on this one. So I know this is 1, 0 and 0, 1 and negative 1, 0 and 0, negative 1. So if I put y over x, this one's okay. It's okay to have 0 in the numerator. This one right here is not okay. This is going to be an undefined situation right here. We can't have 0 in that denominator. So I know I've got one answer right there at pi over 2. This one right here is going to be 0 over negative 1. That's okay. That's going to be 0. And then my last one's going to be right here at negative 1, 0, which you could call negative pi over 2, except that it told me to work between 0 and 2 pi. So I'm going to call that one 3 pi over 2. So anytime we have 0 in that denominator, that's going to be our undefined situations. Okay, on 23, we get started working with some information about our graphs. So let me go just kind of through a quick little review. I'm going to put sine in this. But it could be sine, cosine, or tangent. Let me just kind of run through a little quick review here. And so I know when I'm working with this one, with sine or cosine, and I'm working with my amplitude, I'm going to have the absolute value of A right there for my amplitude. If it's negative, then you're going to have a situation where you're also reflecting. But when you answer the amplitude question, we are going to answer with a positive value right there. Let me remind you for just a minute also that tangent has no amplitude. Amplitude is the idea of how far up does the graph go before it turns and starts to come back down. And remember, your tangent graph just kind of goes on and on forever. Then we're going to ask some questions about the period of these graphs. And so for sine and cosine, I'm going to find that period by putting 2 pi over the b value right here. And for tangent, I'm going to find it by putting just 1 pi over the b value right there. So if you have a tangent right inside there. All right, the other thing they're going to ask you about is the phase shift. So a phase shift is the idea of moving to the left and to the right. It's going to be opposite from what you think inside here. So if I'm moving negative c, that's going to go to the right. And if I'm moving plus c, that's going to move to the left. Again, so opposite from what you would think. And then finally, they'll ask you some questions about the vertical shift. And that's going to work with your d value. This is the idea of how far up and down is it going to move. And that one does go in the direction you would think. So if we're going to add d to the end back there, that's going to move up a value of d. And if I'm going to subtract d, that's going to move down a value of d. So those do go in the direction that you would think. So the questions we're going to focus on this part of the video are just going to be asking you some basic questions about amplitude, period, phase shift, and vertical shift. So we'll come back in the next video and talk about some ideas of shortcuts for graphing using all of that information. But for right now, let's just kind of identify all of the pieces. So on number 23, we are asked to find the amplitude in each case, and we're starting off with f of x instead of y is 1/4 the sine of x. All right, so we just said that we're working with some kind of equation here. See? Where we are working with sine of bx minus c plus d back here. And again, none of this matters right now. All we're focusing on in this video, or in this number 23, is just the amplitude. And so for this question right here, my amplitude is just going to be 1/4. So it's okay for an amplitude to be a fraction. That's going to be kind of a horizontal shrink or a compression. All right, then I'm going to take a look at g of x, which is -5 cosine x. Again, we're only worried about that a value and that amplitude. And again, the amplitude's always going to be positive. So that right there is going to give me 5. Okay, so we do have some kind of reflection. You may want to make a note to yourself about that as you're graphing. But to answer the amplitude question, the answer is just +5. And finally, on this one, we're talking about h of x, which is 7 times the tangent of x. And just like we said a few minutes ago, that amplitude is going to be none. Tangent never has an amplitude because it doesn't go up and come back down. Tangent is the graph that looks a little bit like this. And so it's just going to keep going up and down forever. So it doesn't have any kind of amplitude to go with it, ever. All right, on number 24, then they switch and they start asking about the period on this one. So f of x is 2 times the sine of 4x minus pi. All right, so with period, I only care about this b value right here. And so to find the period on a sine question, I'm going to put 2 pi over b. Excuse me. And let's go ahead and reduce that fraction. Excuse me. And that's going to give me pi over 2 for the period. All right, they also ask me about g of x. Sorry. You can have the parentheses there or not on this one. We are working with a cosine question, and to find the period on cosine, I'm going to do 2 pi over b. b is still going to be that value right there, that 3. And so this one won't reduce, so 2 pi over 3 is the period. And then with h of x, we're working with a cotangent question. So the reciprocals go along with them. So our cotangent is going to go with tangent. Get that one written down. None of this really matters, except for the 2/3 that's sitting right here, this b value. And so to find the period on this one, when we're working with tangent or cotangent, I'm just going to take pi and put it over b. Now I move down here because now I've got something being divided by a fraction. And when I do that, I'm going to keep it, change it, and flip it. And so the period for this one is going to be 3 pi over 2. And then our last question for this video, and the next one we'll get into more graphing information, turn the page, is asking me about the phase shift of each one of these. So let me start with f of x. And so f of x, we're talking about 2 cotangent of, oops, I forgot my 4, x minus pi right there. And with cotangent, secant, cosecant, we're still working with the same idea of phase shift. It absolutely does not matter which trig function you're working with on these. And so I'm going to be looking at this value right here. Again, let me remind you, opposite direction from what you would think. So since we're subtracting pi here, my phase shift for this one is going to be right pi. So be sure when you talk about the phase shift or the vertical shift that you write down the direction and the amount. So two answers there, 2 things that you need to write down for those. All right, on g of x, we are working with a secant value, 3x plus 1. This one doesn't have a number being added or subtracted inside the parentheses here, and so my phase shift's going to be none. So when we go to graph this one, you're just going to start right there at 0 pi. Let me go ahead and make a note, however, that this one does have a vertical shift of up 1 because of this 1 that's sitting right outside here. And then finally, for h of x on this one, I'm working with a sign value, 2/3 x minus pi over 2. So this one right here has a period change, it has a phase shift, and it has a vertical shift. Let me focus on that phase shift first, since that's what the question's asking me. Again, opposite direction from what you would think, so I'm going to take that one to the right, pi over 2. And again, this one didn't ask me about a vertical shift, but this one does have a vertical shift right here. This is going to go up 3 units. Okay, so in the next video, we'll get more into the specifics of actually graphing some of those.